and welcome to Avantika's Notes. In today's note, we're going to talk about CAP Theorem, which is a foundational concept when it comes to designing distributed systems. CAP Theorem says that in the presence of a network partition, a distributed system can provide either consistency or availability, but not both. Let's dive into the video to see what it means. CAP Theorem has three letters, C, A, and P, consistency, availability, and partition tolerance. Let's start with probably the least understood but the most important letter, P. P stands for partition tolerance, or system's tolerance to partition. But what does partition even mean? Partition simply means a divide or split. When parts of your system get cut off from each other, it's a partition. Servers are alive, but they can't talk to each other. In order to understand partition better, let's look at this simple example. Imagine a system that has two servers, server A and server B. Both are connected to each other and data is synced between them. Server A serves the request for some set of clients and server B for the other set of clients. All the writes that happen on server A are synced to server B and vice versa. This means irrespective of which server the client is connected to, all of them are going to receive the same information. What happens if this link between server A and server B breaks? It means that server A and server B will no longer be able to sync data. All the writes that are happening on server A may not get synced to server B and vice versa. This is called a partition. Partition can happen anytime. A network cable can break, a router can crash, or a natural disaster can happen. In real world, network failures are unavoidable and partitions are not rare. Now, if you think like a system owner, do you think you would want your system to stop responding every time there is a network glitch? Of course not. You would want your system to keep responding even when there is a partition. This ability of the system to keep functioning even during partitions is called partition tolerance. Now let's move on to the next letter, A, for availability. I'm sure most of us understand availability pretty well. It means that the system is responding. If we ask for something, the system gives us a valid reply. Now let's try to understand what it means to have availability with partition tolerance, or a system that has chosen AP. Imagine this system that is a travel booking website, where we again have two servers, server A and server B, which cannot talk to each other because of a partition. There are two flows, a write flow that admin is adding new properties to the database, and a read flow where clients or the travelers are searching for properties to book from. Because of the partition, all the writes that happen on server A will remain on server A, and the reads that happen on server B can no longer access the properties that were added to server A. This means if this is a property listing that is visible to client 1, then the property listing that is visible to client 3 can be different in terms of this property, Estrella Domar Beach Resort, is visible on server A because it was added by client 2 and is not visible on server B because it has not been synced to server B. So this travel website decided to have availability with partition tolerance, and they compromised with consistency. When they made this decision, they made it knowing that whenever there is a network partition between their servers, their property search page will continue to be available and serve travelers' requests. Even though some of the travelers might see inconsistent results, but if you think from a traveler's perspective, you already have hundreds of properties to look at and search from. So a couple of missing properties or additional properties aren't going to even be noticeable. So this is what AP stands for. The next letter in this theorem is C for consistency. Consistency means that every user sees the same data, irrespective of the server they are connected to. Now let's look at a system that has chosen consistency with partition tolerance, or CP. We'll take a banking system example to understand CP. So Tom and Jack are two clients of a bank. Tom's requests are served through server A and Jack's requests are served through server B. When there's no partition and Tom and Jack check their balance, Tom's balance is $1,000 and Jack's balance is $500. Then Jack sends money to Tom, value $100. After this transaction happens, both Tom and Jack's balances are updated. So Tom now has $100 more and total value being $1,100, while Jack has $100 less, total value being $400. There is a consistency in the balances that both the clients are seeing. But what happens if there is a partition? After the partition happens, Jack sends money to Tom, value $100. This time, because of the partition, Jack's write on server B could not be synced to server A. So when Tom read his balance, it was still $1,000, but Jack's balance was updated to $400, which means that there is now an inconsistency between the two clients' data. And this is bad for a bank. This inconsistency happened because there was a partition and the system was still serving requests. The problem occurred because there was a write that happened after the partition. So, one simple way a banking system can avoid this inconsistency is stop doing writes whenever there is a partition. This is, of course, one possible way of handling CP. There could be others, but for this example, let's say the bank system avoids doing writes whenever there is a partition. So this means there can be no banking transaction that will update the balance of the clients. So clients that are doing a read on their balance will always continue to get the consistent data. So banking system chose consistency during partition, ensuring that their data remain consistent while compromising on the availability of the writes. So now we know the big trade-off that CAP theorem teaches us. When a partition happens, if we choose consistency, we pause some requests till the servers catch up. That hurts availability. And if we choose availability, we allow each server to serve the requests even if the data differs a bit. So CAP theorem is about deciding what is best and what matters the most for your system. I hope this note was useful and it will help you in your day-to-day work or if you're preparing for system design interviews. See you in the next note. Bye-bye.